Assalamualaikum and good day. Today we're going to continue our first chapter, which is General Principle for Static. As you can see here in your handout, you can see what is the aim for each chapter, explain, and also the expected outcomes. And this is the chapter outline. What is mechanic? Mechanic is a branch of physical science that is concerned with the state of rest or motion of bodies that are subjected to the action of force. It can be divided into three branches, as you can see here: rigid body, deformable body, and fluid. For engineering mechanics, we covered rigid body. It is essential for the design and analysis of many types of structural members, mechanical components, or electrical devices encountered in engineering field. For the rigid body, we can divide it into two, which is static and dynamics. For the static is equilibrium of bodies at rest or move with a constant velocity, while for the dynamic is an accelerated motion of bodies. It is important to understand the meaning of certain fundamental concepts and principles. These basic quantities are used throughout engineering mechanics. Honestly, until the end of our lives, we need these basic quantities. For the basic quantity for the length, as you can see here, L, it used to locate from one position of point to another point, so that is length. Then time, T, it is a succession of event, as you can see here in here, no plant, and finally we have a tree. That is succession of events. The next one is mass, measure quantity of matter. It manifests itself as a gravitational attraction. And the last one is force, F. As you can see here, here is force of pull, and here force of push, and we need force to ensure this object can move. So that is basic quantities. In engineering mechanics, idealization are used in order to simplify application of the theory. Here is three idealization. The first one is particles. For the particle, the geometry of the body will be negligible. Take as example, size of the Earth compared to the orbit. Therefore, is modeled as a particle. Can be circled like this. And then rigid body. Combination of large number of particles and the shape of body didn't change when load is applied on that rigid body, and this suitable for analysis. The next one is concentrated force. It represents the effect of loading which is assumed to act on a body. For example, as you can see here in picture, the wheel train on the track. So we can simplify with single concentrated force on the wheel. We take on this side, this is the wheel. This is the track. And here is a concentrated force. For engineering, It's formulated on the basis of Newton's three laws of motion. First law, particles in rest position or no motion not subjected to unbalanced force or outside force. And this event explain those three laws. And please play this movie in your slides. And also, please think about this event. Why this thing is happen while driver take a corner while driving the car. The next one is Newton's second law. A particle in the motion which produce an acceleration. Force is F, acceleration is A. F force equal to mass time acceleration. The next one is Newton's third law. Action and reaction force between two particles are equal. If your action equal to FAB, N means the reaction is negative FAB. The same force but in different direction. That is about Newton's third law. Shortly after his three laws, Newton formulating a law of gravitational action between any two particles. And it's quite familiar for you about this event. What is Newton's invented in our life? It is about the gravity. And please find about this Newton's law more in Google or any textbook. Is widely explained about his theory. And in this one, about the attraction between two mass 1 and mass 2. And R is distance between two particles. So please find more about these things. It's good to know. For this force, termed as weight, will be only the gravitational force considered in our study. Take for an example, for this astronaut weight is diminished since out from the gravitational field. That's why this astronaut is floating, because there is no gravitational force between two particles. So we can idealize this astronaut as one particle, and we can idealize us as one particle, another M2, and R between these two particles. However, there is no gravitational, no G. On the Earth, we take the gravitational force as G, and the unit is 9.81 ms square. And throughout our life, we need this G. Thus, weight is mass times G. And also, please find what is the difference between F equal mg and F equal ma. Refresh back about the basic quantity. We have length, L, we have time, T, we have mass, small m, we have force. Those are basic quantities. And for the International System, or SI, which is abbreviated after French system, International D unites, and normally we just call is SI. For these basic quantities, length, time, mass, and force, it has its own unit. which is, as you can see here, for length is meter, small m, for time is second, small s, and for mass is kilogram, kg, and for force is Newton, capital N. So this is the basic units you have to remember. Take for an example, we have 1 kg and we have mass of 1 kg, and we want to know the weight, and the weight for this one is 9.81 Newton. That you have to remember, and I assume you learned it previously during your physics. Remember, G equal to 9.81 ms square, and this N, capital N, derived by kg ms square. And also recall back previous notes, W equal to mg, and also F equal to ma. Now we move into the prefix. For sure you remember about this, what is kilo, mega, giga, and tera, and also you have to remember the symbol for those. So this is my step how to remember. Here 0, 10 power of 0, we have kilo, K, kilo, mega, capital M, we have giga, capital G, we have tera, capital T. And for this one, for kilo is 10 power of 3, mega 10 power of 6, giga 10 power of 9, tera is 10 power of 12. Next, for the small things, we have milli, small m, then micro, we have mu, and nano, small n. For small particle or small things in our life, we have milli is 10 power of negative 1, micro is 10 power of negative 6, nano is 10 power of negative 9. So once again, you just remember here 3, 6, 9, 12. Then for milli, negative 1, negative 6, negative 9. So this for something bigger, this for something very small. So we take as an example for bigger number or value. For example, 1 power times 10 power of 3. So equal to 1 times 1000. How we define that? So start from here, next to 1, 1, 2, 3. So we have 3 0. That's why 10 power of 3. So this one equal to 1000. So this something for bigger number. Now we take for small number. For example, 1 times 10 power of negative 3. So equal to 1 divide 1 times 10 1 divided by 1 times 10 power of 3. This equivalent to when this going up or across, we get -3. Similarly, this one is 1 divided 1000. Easily, you have 1 and you have 3 0. This means start from here, 1 2 3. That for 3 0, when it's a negative, we get this one, 0.001. So the answer for this one is 0.001. So this is the thing, how to remember and how to convert from small number or bigger number. Now we move into another example for large quantity and small quantity. You know, kilo is prefix in here and Newton is unit. Now let's take for large quantity. The first one is 5 million Newton equal to how many zero? 1 2 3 4 5 6. So 10 power of 6 is mega. So 5 times 10 power of 6 Newton, and 10 power of 6 is mega. And also from mega we can convert it into kilonewton, equal to 5 times 10 power of 3 times 10 power of 3. And don't forget the units is Newton. 3 plus 3, we get 6. Kilo plus kilo, we get mega. So this one we can simplify. For 5 times 10 power of 3 is 5 times 1000. So we get 5000. And 10 power of 3 is kilo. So kilo Newton. Or we can write as 5 mega Newton. So this one is prefix and Newton is unit. So when we converting, we need to use suitable prefix and do remember the unit. Now we go for small number or small quantity. Take for example 0.004 meter. Our unit is meter, so we're going to convert it into suitable prefix. How many zero we have here? 1 2 and 3. So equal to 4 times 10 power of -3, and the unit is meter. 10 of power of -3 is milli, so the answer is 4 millimeter. So this prefix and this is units. So we done on small quantity and large quantity. And please do remember the rules. First one, multiple unit must be separated by dots. For example, Newton, kg.ms.s -2. You can write in this form or you can write into this, but remember the dots. The next one is exponential power of the units. Here this example, these things mean into this and into this. We take this as example, square, similar to time So this is what this mean about. Next one, convert all prefix into power of tens. For example, in here we have 50 kilonewton times 60 nanometer, and we get the answer 3 millinewton meter. So we have to convert all prefix into power of 10. Later on we're going to see this example, and also all the symbol of prefix in lowercase except for tera capital T, mega capital M, giga is capital G. Please do remember that one. Next one, with the exception of base unit kilogram, avoid use of prefix in the denominator of composite unit. Here is the example, nano we convert it to kilonewton over meter, and next one is meter over milligram. We can convert it to megameter over kilogram. So please remember this basic rule for the conversion. As I said, we're going to touch on the number 3. Let's do for that one. 50 kilonewton times 60 nanometer. So 50 kilonewton, 50 times 10 power of 3 Newton. Then we have 60 nanometer. Nano 60 times 10 power of negative 9. The unit is meter. Next one, we have 10 power of 3. We have 10 of negative 9. 3 plus negative 9, we get 10 power of negative 6. 50 times 60, we have 3000. 10 power of 3 times 10 power of negative 9. 3 plus negative 9, we will get 10 power negative 6. And the unit for this case is Newton times by meter. So Newton dot meter. Then for this one, 3000. 1, 2, 3. 3 times 10 power of 3 times 10 negative 6 nanometer. What we have, we're going to have 3 times 3 plus negative 6, we have 10 power of negative 3 nano Newton meter. 10 power of 3 is milli. 3 milli Newton meter. So that's solved. For the rule on numerical calculation, it must be dimensional homogeneous, which is must be in system unit, which is as in the same SIU system, and then significant figure SF. Take here as an example, 26,300 is 5 significant. We can write in 3 significant. That means just left 3 number, which is 2, 6, 3. When we going to write in 3 significant number, we have to move point at the end to the front. 1, 2, 3. And we will get 26.3 times 10 power of 3. And this one is 3 significant. Next one, take an example, 0.000662. That is 6 significant. So 1, 2, 3, 4, 5, 6. So that's 6 significant. If we wish to write in 3 significant, that means just left 3 numbers, which is 3 significant figures, 1, 2, 3, 6, 6, 2, and we will have 0.662 times how many points we move? 1, 2, 3. 0.0062 times 10 power of 3. That in 3 significant figures. And also, we can write into 662. And for this case, we have to move 1, 2, 3, 4, 5, 6. So we have 662 times 10 power of 6, and this also 3 significant figures. Also, in numerical calculation, for example, we will ask for you to write into 3 decimal, and you have to know how to write into 3 decimal number. And when we ask you to write into certain significance, you have to know how to rounding off those numbers.